Today's mini lesson and tomorrow's mini lesson are going to be review problems of things that you've already seen before, and they're problems that we found some people were either struggling with, or a lot of students were making common mistakes overall as a grade. So we figured it'd be good for you guys to review for today's task, which is all review on quadratics, and next lesson's quiz, which would also all be in quadratics. So these are questions that you're going to be seeing today and the next lesson, so you want to make sure that you know how to tackle them. So the first question that we have here says, on the set of axes below, graph the following systems of equations. So if you don't have a printed copy of this, you do not have to graph it. You will, however, be writing everything else that I'm writing down on a separate sheet of paper. So you don't have to graph, but everything else has to be done on a separate sheet of paper. So we have two equations. I can already tell one of them is quadratics. There's an x squared over here, so I know that that's going to be a u. And I can tell this other one over here is going to be a line because the biggest exponent is a 1, so that's a linear equation. So I have a system of a quadratic. And linear equation. And they're asking me to graph these two lines and determine the coordinates of all points. That's keyword, all points. That means that there might be more than one in the solution set for this system of equations. Now, if you notice, I have two equations and I don't have y by itself in either of these two lines. Now, if you go back to when we first started graphing, remember when I told you guys that the very first thing you want to make sure before you graph, I cannot put anything in y equals unless my y is by itself. So what I have to do first is take both of these equations, and we're going to go ahead and get y by itself for both of them. So I have the first equation, which is y plus 2x equals x squared plus 4. And now I'm going to get y by itself, so the easiest thing to do is just move this 2x to the other side. Remember that in order for me to move things from one side of my equal sign to the other, I have to use my inverse operations. So if this is a plus 2x, I have to do a minus 2x to bring it to the other side. And so I have y equals, and I can simply just bring everything down. However, when I bring everything down, I'm just going to write it in order so that it looks like everything we've been graphing and working with before. So I have my x squared. I'm going to write it in standard form. After my x squared comes my negative 2x. And after that minus 2x comes the positive 4. And that's the first line that I have here to graph. So I'm going to put that in y equals. I'm going to go to my graph, to my table, second graph, and I'm going to start plotting my points. There's two ways you can do this. What I've been teaching you guys before is that you want to always start with your vertex and then add all the points after that. Okay? Now, if you look at the table, you get the table that looks like this. You have negative 1, 7, you have 0, 4, 1, 3, 2, 4, and 3, 7. And those are the only points that I can fit. Anything else after that or before that has a y value that's bigger than what I can fit in here. So my vertex here, again, if I look on the y values, the only y value that doesn't have a pair, right? 7 has a pair with a 7, 4 has a pair with a 4, but this 3 over here is lonely. That's the point where everything starts to repeat again, so that's my vertex, and that's what I'm going to start plotting. So I have 1, 3, and then I'm going to plot everything after that. I have 2, 4, I have 3, 7, 3, oh my gosh, 3, 7, and then everything before that, so 0, 4, and negative 1, 7. And now I can connect my graph, I can connect my points, draw my arrows, and don't forget to label. You must label. So I have y equals x squared minus 2x plus 4. Now I'm going to do the same thing with my other graph. So I have y minus x equals 4. And again, I'm going to get y by itself. I'm going to put a 1 right here. And to get my y by itself, I need to get this negative 1x to the other side. Since it's a negative, I'm going to add 1x to get it to the other side. This is overview. And I get y equals 4 plus 1x. And again, I put that into y equals. And I'm going to graph everything that fits on my table. And you're going to see it's a lot of points, and you want to graph everything that fits. So I have the following points. Already I see a point right here, 0, 4. And I'm going to keep adding all the points that fit. Okay, once I've plotted all the points that fit, I'm going to go ahead and connect my points using a straight edge. And I'm going to label my graph. So now that I've graphed and I've labeled, I'm going to check where do these two lines connect? Where do they intersect with each other? Where does the curve meet with the straight line? And those intersections will be the solution to the systems of equation. So I see that they share this point in common over here, which is the point 0, 4. And I see that they share this point here in common, which is the point 3, 7. Okay, so the solution, you should be writing everything down except the graph if you don't have a printed copy. So the solutions to this system of equations are the points 0, 4 and 3, 7. Now, since we're not going to be graphing because we don't have a printed copy of this, most of you guys won't have a printed copy of this, you can also double check your work by using your calculator. So if you put both of these in y equals, you put this in y1 and then this in y2 and go to second graph. So you go to your table, you want to look to see where's y1 equal to y2. And in this case, I see that they're equal to each other right here. They're equal to each other right here. So my solutions are the point 0, because this is x, 4, because this is my y value, and 3, again, this is x, comma, 7, which is the same thing we got by graphing. So once you're done writing down the details of your mini lesson, what I want you to do is get y by itself for these equations, and I want you to find the solutions using the calculator. Okay, so using the calculator, I do not want you to graph. You will be turning this in as part of your task, so make sure that your mini lesson and this problem is submitted along with the rest of your task that's attached on the Google Classroom link. If you do not submit this problem with your task, I will not be giving you full credit. So make sure you do this as well. Here, all I want to know is see you get y by itself and give me the points where they're both equal to each other. Good luck.